In this video, we're going to look at hypothesis testing for the mean of large samples. So first, we need to be able to find critical values for rejection regions. When doing this, we want to begin by specifying the level of significance, and we're going to then have to determine, are we looking at a left or right or a two-tailed problem? If it's left-tailed, we're going to use the norm.imv, and we're just going to plug in the alpha value given, and then 0 and 1 because we're going to use a z-score. If it's right-tailed, instead of alpha we use 1 minus alpha so that we can get that upper region. And if it's two-tailed, we take our alpha and divide by 2 with the same formula. Now with the two-tailed, you can see we get two different values. So we get the negative with this version, and then we also do the positive. And once we have our alpha values, we're going to draw that in and shade the corresponding portion on an actual on a standard normal bell curve. So let's look at two examples here. Say I want to find the rejection region for a left-tailed test with an alpha of 0.03. So I can take, since it's left-tailed, I just plug the alpha directly in, and I'm going to get that the z naught is negative 1.88. And if I put that onto the bell curve, I put negative 1.88, and it's left-tailed, so I'm shading to left. So that shaded part there is my rejection region. If I wanted to do a two-tailed test for alpha of 0.03, I'd first want to find the lower tail, and I get negative 2.17. And then I also know that the upper tail is the positive version of that, so positive 2.17. And I place both of them onto the standard normal distribution graph. And here are my two rejection regions in this case. Now, if I want to use those rejection regions to help me run tests for the mean, first thing I'm going to do is I'm going to state my claim, my null, and my alternative hypothesis. I'm going to specify that level of significance. I'm going to sketch that sample distribution like we just did. I'm going to determine what are those critical values in rejection regions and place those on the distribution. And how I'm going to use that is I'm going to then find the z-score for the information that I have. I can place that z-score on my sampling distribution I've created here, and if it falls in the rejection regions, I'll reject my null hypothesis. But if it does not fall in the rejection region, I will fail to reject my null hypothesis. Once I've determined which I will do, I do go and interpret the data as well. So let's say that Tony's Pizza guarantees delivery in less than 30 minutes. And we're going to look at a sample of 40 deliveries, a mean time of 27.2 minutes, and a standard deviation of 5.4 minutes. And we want to know whether or not there's enough evidence to support this claim at the 0.05 level. So first thing we do is we say the claim is the delivery is less than 30 minutes, and we create our null and our alternative. Remember that since this is an inequality, that's going to be our alternative that we're trying to see if that's true or not. Since it's less than, it's going to be a left-tailed problem, so we use the z naught of norm of 0.05 here for the formula in Excel, and I get a value of negative 1.645. So I'm going to go on and graph that, and you can see here's my negative 1.645, and my rejection region is everything to the left in the shaded area. Now I can find my z-score for my sample. In this case it's 27.2 minutes. I'm testing at 30 minutes. My standard deviation was 5.4, and it has sample size of 40. When I simplify this entire fraction, I get negative 3.28. That falls right here, and that is within my rejection region. So I will reject the null hypothesis. And my null hypothesis was that the mean was greater than or equal to 30 minutes. So what this means is at the 5% level of significance, there is sufficient evidence to conclude that the mean delivery time is less than 30 minutes. Let's look at another example. Say a local store creates an ad suggesting their average item is $5. And you believe that is false, so you go to the store, you sample 50 items and find the mean is 547 with a standard deviation of $2.25. And you want to know, is there enough evidence to support the store's claim at the 0.01 level? So the claim is that the average cost is $5. So that would mean our null hypothesis is that the mean is equal to $5. The alternative would be that it's not equal to $5. So we're actually going to test the null. It's a two-tailed problem, so the first thing we do is we find the negative z0, and that's negative 2.56. So the positive would be positive 2.56. And you can see that in the graph here. And the shading is on the outside tails. Now I'm going to find the z-score that relates with the sample information. So $5.47 minus the mean that we're testing against, $5, our sample deviation, and our sample size, and I get that the z-score comes out to 1.48. That falls right here, which is in the area that I would fail to reject the null hypothesis. So in this case, at the 1% level of significance, there's not significant evidence to conclude the average cost for an item is different than $5.